Hello, grade 10s. Welcome to our first naming compounds lesson. We are going to do a series of lessons on naming different compounds. We are starting with the most simplest one, which is naming ionic compounds. Let's start with a little bit of a recap of what we learned on Wednesday. So at the end of the ions lesson, we talked about forming compounds and ionic compounds. So just to recap, a compound is a substance that has two or more atoms that are chemically combined. When the chemical compounds are formed, they like to have a valence shell that looks like the nearest noble gas. So full valence shell, we call that the octet rule. So it wants to have either a full or an empty shell. There's three ways that atoms or elements will do it: giving up electrons, gaining electrons. Remember we talked about how those affect the charges. And the last way is sharing electrons. So these two are relevant to making ionic compounds because they make ions. This one is relevant to covalent compounds, which we'll talk about later down the road. Alright, so ionic compounds. The most important thing I want you to remember is that ionic compounds are always formed between metals and nonmetals. So check your periodic table. You color-coded your periodic table, right? So the metals are on the left-hand side and the non-metals are on the right side. So check your periodic tables. Alright, on to the actual naming. So here I have some examples of simple ionic compounds. We call the left side, this is the chemical formula. It's written with the chemical symbols. Let's write that. Chemical formula. We call the right side, that's the chemical name. So when you write a chemical compound, like on a lab, when you do some explosion, let's say, you probably want to write using the chemical formula. It's much shorter, it's much quicker. When you read it though, when you read it out loud, you want to read it like the chemical name. So Al2S3, we read it aluminum sulfide. LiBr, we read it lithium bromide. BeCl2, we read it beryllium chloride. CaF2, we read it calcium fluoride. I'd like you to take a moment, maybe 30 seconds, and tell me, what kind of patterns do you see? Maybe you can tell somebody next to you since I'm not there. So maybe take a notice. What about the endings? What about the names? What do you notice? Maybe compare it with the periodic table. I hope you told somebody next to you. Something I notice is that all the metals end with This is what somebody told me earlier, actually. But you know what? That's just what all metals, their ending just happens to be all endings. Why? I'm actually not quite sure. Maybe you can look into it. the most important one is my second element. All their endings have changed. Instead of sulfur, we have sulfide. Instead of bromine, we have bromide. Instead of chlorine, we have chloride. And instead of fluorine, we have fluoride. So let's write that into rules. Alright, I want you to write this down in your paper. Before you name a compound, this is important. You always need to check and ask, is this ionic or is this covalent? And how do you tell ionic versus covalent again? Remember, ionic is always between a metal and a non-metal. So check your periodic table and check, where are my two elements? Is it a metal and a non-metal? If yes, then you proceed with this rule. So we are only naming simple binary ionic compounds right now. So that means a simple metal and a non-metal. And simple metal, we are referring to any metals that are in group 1 and 2 plus aluminum. It just happens to be kind of on its own, but aluminum is also a simple metal. So basically not transition metals. So when you have those plus a non-metal, we just name the metal and the non-metal, and then we change the non-metal with the "-ide" ending. So that's the most important part, the "-ide" ending. Let's try some examples. NaCl. Check your periodic table. You should have it right next to you. Find Na. It should be in group 1. So Na is sodium. It's a metal. A simple metal, in fact. So I write sodium. Cl. I want you to find that in your periodic table. It should be in the non-metal section, probably group 17. It's chlorine. But instead of chlorine, I do the "-ide" ending. So we will write chloride. And that's it. Nothing much to think about. Pretty simple. Let's do the next one. Mg, that's a metal in group 2. O is a non-metal, if you check your periodic table. Mg, you should find it in group 2. It's called magnesium. So let's write that. O is in the non-metals. It's oxygen. So we're going to change to the "-ide" ending. And it actually becomes oxide, not oxygenide or oxygide. It's just oxide. You gotta do a bit of practice to figure out what the ending will be.